Hi everyone, Jason from Makera here with another project tutorial, and in this one we're looking at how to create a Trammel of Archimedes using Makera CAM and the Carvera Air Desktop CNC. The Trammel of Archimedes is a well-known ellipsograph, which is a mechanical device that assists in creating mathematically accurate ellipses. And for educators looking to bring these concepts and this project into your classroom, we also created the Evolutionary Ellipsograph Lesson Plan, which offers not only tutorials and example files, but also all of the instructional resources you need to support your students as they engage with subtractive manufacturing. And for anyone looking to recreate this project with me, we've also shared the models and CAM files for two different versions on our wiki site as well. The simpler version is designed for a simple 2D and 3D machining operation, while the more complex version requires some additional post-processing steps. We'll be looking at the more complex version in this tutorial, but the general techniques and procedures are the same for both. So let's dive in.
All right, so after you download your file from the wiki, or if you create your own file in some type of CAD software, we can launch Makera CAM, and we need to set up our project. And this will actually end up being two separate CAM files, one for the base part of our trammel, and then one for the pen holder and other components you need. So starting with the base part, we can edit our stock, and you'll see that I've selected brass because that's what I'm personally using for this project. And I'm going to be using a piece of brass that's 100 by 100 by 8 millimeters in size here, right? So I can go ahead and set those parameters. When you set your stock out here, your stock material, it will automatically default your feeds and speeds for your toolpaths, which is something that we'll see later on. We can then go ahead and import our design file. So I'm going to import the 3D model for the base part, which is our body step file, which you can see imports here as a 3D model. And we just want to orbit around and make sure that that's in fact aligned where we want it to be on our stock. But if it didn't, if you had to make any adjustments, you can always select your model, then go into the transform and move tools, and you have some ability to adjust your positioning here. You also have this quick align button, which should automatically center your part in the X, Y, and Z locations, as mine did by default. So now we're ready to start to create our toolpaths. And the first toolpath we're going to make is actually going to be surfacing our stock. Because if your part goes all the way to the top of your stock like mine, where you're actually going to be using the top of your stock on your part, you might want to surface it, or machine the surface of it, I should say, to give you a better and higher quality finish, right? Because your stock might be rough cut, it might be typically brass doesn't have a great surface finish. So if we can machine this area just a little bit, it'll give us a better quality upper surface. They'll also allow us to make sure that our surface is perfectly square if it is rough cut or some type of extruded stock. So how do we do that? Well, in theory, you could create a pocket operation that would just machine like these areas. So for example, if I made a 3D pocket and then clicked on these areas, it would machine these little wings of my base part here, but not necessarily all of the inner areas, and that might not be the most efficient way to actually machine this part. So another thing you can do is generate a contour around your 3D model. Like for example, if I use the trace feature to trace a 3D contour, we now have these 2D contour paths that were generated, and we can use that to create a very simple 2D pocket. So for example, if I click 2D pocket, I can select these components here, like so. I can select this path, here. And what we want to do is set an end depth of just a little bit to machine the surface away of our stock. So for example, 0.1 millimeters, just to machine that away. I then want to make sure that I have the right feeds and speeds selected. So I'm going to choose a single flute bit for metal, specifically a 3.175 bit for metal here by 25 millimeter in length, and my feeds and speeds for brass, like so. And I'll delete the other one that I didn't mean to keep there. Okay, so we have the right feed and speed parameters. Our strategy, I'm going to keep offset because I'm going to follow around the contours of this part. If you were surfacing a large square area, you could use parallel, which might be a slightly quicker operation. And then we just want to enable ramping. And what that will do is it will give us a gradual entry point as our bit enters our stock to make sure we don't put any extra load or shock our bit. So let's calculate that. And it's a little difficult to see because it looks like my part is just slightly taller than 8 millimeters, right? So my my part is actually just sticking above my stock, so it's difficult to see my toolpath in a lot of really good detail. But if I hide the part just temporarily here, you can see that we've just machined this area, this total profile, which will give us a really nice surface finish. All right, so let me bring the part back, and I'm going to hide these paths, and I'll hide this path, so then we can proceed to our next toolpath. The path is going to be this inner pocket that we have here for our slots and the slides of our Trammel here. So let's go ahead and create a 3D pocket. We're going to select this inner path, and up top, we don't have to change anything here other than making sure we have the right bits selected. So I will select again my single flute for metal, 3.175 by 25 millimeter end mill. Make sure that my feeds and speeds are set for brass, like so. Default feeds and speeds are fine, and I'll make sure I have the same tool number because it's the same bit that I just used earlier. Again, I'll keep offset as my path strategy, and you want to make sure that you have outside boundary enabled for your tool containment. What that means is it will allow the tool to actually exit the area that you've selected, right? So if I had inside boundary selected, it would basically mean that my bit can never travel outside of this area. And if that's the case, then I'll never be able to machine these edges, right? I need to be able to cut past the edges just a little bit to be able to machine the area. So therefore, outside boundary has to be enabled. We want to make sure that we have ramping enabled again, so that way we reduce the wear on our bits. And then we can calculate this toolpath. And then just one more toolpath for this part, and that's going to be a 3D contour. So let's go ahead and select our part, and we can generate a contour right here in the toolpath operation. And we're going to select the bottom outer contour that we can use to actually cut this part out. We also typically want to adjust our end depth offset, right? So what I have here is I have a small end depth offset of just 0.1 millimeters. And that means that we'll actually machine 0.1 millimeters past the bottom of our stock, just to make sure that we cut all the way through, which is important. We can then choose our tool, which I have the same tool as I selected earlier. So my 3.175 by 25 millimeter end mill for metal with my brass feeds and speeds. And then we just need to select our strategy. And for this one, we want to make sure we have an outside strategy. That means that the bit will follow along the outside of our part, where inside it would actually run on the inside, which would, in this case, shave some material off my model dimensions, and then on vector would sort of split the difference. So we'll keep outside on. We want to enable ramping, as we did before. And then we have to consider whether we need tabs or not. Once we cut all the way through our material for this part's going to be loose, and it could vibrate, it could move, it could collide with the bit, it could, in theory, eject from the material, right? And all of that is not ideal. That could be dangerous, that could break some bits. You want to avoid doing that, right? So what you could do is enable tabs, like for example, custom tabs here. And I could add some tabs by just clicking on my contour profile, right? So let me add some tabs on like the ends here. And if I calculate this, you'll notice that when I zoom in on this machine area, there's a small not machined section. In this case, a triangular not machined section, because I have triangular tabs enabled. And then in post-processing, after it's done machining, you could use a saw or a file to actually cut those tabs away. But when you're working with a harder material like brass and metal, sometimes cutting tabs can be rather difficult. So it might not be the best option depending on the finish quality of what you're looking for your part. So I'm going to clear these tabs, and I'm going to recalculate without any tabs, because I'm going to use double-sided tape, which isn't always the best option either, right? So double-sided tape, you might not get good surface area contact. It could release, so you have to be careful with that as well. It's certainly not a perfect solution. So you sort of have to choose which option is best for the specific project that you're working on, the specific case scenario that you're working on. Another one that you could potentially consider doing instead is, for example, instead of plunging all the way through, you machine to like 0.1 above the bottom of your stock, just barely above the bottom of your stock, to leave the thinnest amount of metal holding your part and then cutting that away. But that also takes some practice and finesse to get that right as well. So there isn't one perfect solution. You sort of have to, again, choose the best compromise for the finished quality, the part, what you have resources available. So here we go. That should wrap up that toolpath. And I'll enable this one again. And before we go ahead and export these toolpaths, let's simulate our job. We can preview these. So I'm going to select all three here. And let's go to our toolpath preview, like so. And we'll speed this up just a little bit. And this will allow us to check the quality and operations here. So we see that we surfaced the part first. Now we're machining this pocket. I'll speed it up just a little bit. So we're machining the pocket area, like so. There's our outside containment. You can see the tool has to exit and enter, right? So that's our outside boundary that we set. And now it's doing the contour. And you'll see that it's going to plunge all the way through my stock, no tabs, holding it in place. Because again, I plan to use double-sided tape. All right, so that looks great. So now we can exit this and we can save or export these code files for manufacturing. You could choose to separate them into separate jobs if you wanted. You could also use this time to double check your tool number and make sure all your operations are correct as so. And then once you're ready, export these and we'll upload those to our machine later on. So with that saved, let's create a new CAM document for all of the pen parts and pen components. Now we're going to need a slightly different size stock for this, which is why we're doing these parts separately. Let's edit our stock parameters. And for these parts, I'm going to use stock that's 100 in length, 100 millimeters in length, but only 45 millimeters in width and 15 millimeters in height. So that will adjust our stock size. Let's go ahead and then import those models. And you'll see that we have our parts here that, again, you can grab from our wiki. And you'll notice that these parts are quite a bit taller, which is why we need our 15 millimeter stock. Now, you'll also notice that there's holes on these parts that are on the side, right? And you could, in theory, do this with, let's say, a fourth axis operation, which is not what we're looking at in this tutorial. Or you can drill and machine these holes in post-processing. For the sake of this tutorial, we're going to keep this at more of an intermediate level. So we'll assume that we're machining these holes in post-processing later on, and we're going to look at actually creating these parts in a 3-axis configuration. So let's start by actually drilling these larger holes on our slide pieces with a 3D drilling operation. We can select the bottom of these 2 holes, hold shift to select more than one at a time, and it's going to automatically figure out the depth of these holes, which should be somewhere around 7 millimeters or so based on my design there, though you could offset this to go a little bit deeper if needed. Let's go ahead and select our drill, which in this case, I'm going to select a 3.175 by 12 millimeter drill with brass as my feeds and speeds here. And then we want to enable relative retract with a retract of 1 millimeter, so that way it doesn't just like plunge straight through. It actually retracts and does a peck drilling operation, and we can go ahead and calculate that toolpath. Now, you could also do this with a milling operation as well. So if you didn't have the right drill bit, or if you want to machine these out with a milling operation, just choose an end mill that is smaller than these holes to make sure that they fit within the holes, so that way you can actually clear this out as, let's say, a pocket operation instead. All right, next toolpath, still looking at the slides, is we're going to create a 3D pocket to surface down to the face of these, because as you can see, the face of these guys is quite a bit lower than the actual thickness of our stock. So let's create a 3D pocket, and we can hold shift to select both surfaces of these parts here, like so. And let's go ahead and select our end mill that we did earlier, which would be our single flute 3.175 by 25 millimeter end mill, brass as our feeds and speeds. And I'm not going to change the defaults. What I am going to change, though, is the tool number. So notice that right now my drill was set to be tool 1. I want to make sure that my end mill is set to be a different tool, for example, tool 2. So that way the Carvera Air will automatically pause and prompt me for a tool change after the drilling operation was completed. Path strategy, I'm going to head and enable offset instead, just so it follows the contours of these parts. We'll make sure that outside boundary is enabled like we did earlier, and we'll make sure that ramping is enabled as well. So if we calculate this, we'll now see that these surfaces are machined around the posts that will remain at the stock height. And one more toolpath for these base parts, I'm just going to hide the 2 that we did earlier so you can see this a little bit better, will be a 3D contour. So I'm going to click on my parts here, and it'll automatically select all of the model, and that's fine. And I'm going to generate my contours. And then by holding shift, I should be able to select the two contours for these slide parts at the same time. Again, we'll do a manual offset for the end depth of 0.1 millimeters. And we will select the correct tool, which will be our 25 mil at brass feeds and speeds, and also make sure that the tool number corresponds to what we did earlier, which would be tool 2, or else you'll be prompted for another tool change. Outside strategy like we did earlier, ramping like we did earlier, and then again, the same debate on whether you want to use tabs or double-sided tape to secure your parts. All right, so now with these 3 toolpaths, we have our slides. And if you want, you can pause at this point and actually simulate this and just simulate these 3 here. So if we preview this, I'll hide the model so we can just see our cuts here. We can speed this up a little bit. We should see these slides being machined using those 3 toolpaths. And that looks great. All right, let's exit the preview. And now let's work on these other parts. We can do this, the rod holders, these little pin rod holder pieces. So for those, what we're going to do is create, again, this surface cut here. And this is a much smaller and concentric area. So we could choose to machine these surfaces using a pocket operation like we did earlier. We can also choose to machine them using a contour operation where it actually just follows around and does a 3-dimensional contour. Both would work in this case scenario. I'm going to do a pocket just like we did earlier, just so I can easily select these faces. And let's make sure that our settings are correct. So we have our end mill with the same feeds and speeds for brass. We'll make sure that we have an offset strategy. So the end mill will just machine this pocket around this center post, and outside boundary and ramping. So that will go ahead and machine this. Perfect. Then we just need another contour toolpath. So let's go ahead and create a 3D contour. We'll select our object here and generate the contours. And I can just choose by holding shift and select these 2. And end tip offset is automatically set to be what it was before. Our bit and everything like that was set what it was before. So we shouldn't have to do anything other than enable ramping and then again choose whether you want tabs or not, like we discussed earlier. Perfect. All right. So now all we have left is this outer part here, which is for the marker. So this is your marker or pen holder. So let's first clear out the inside. And for this one, I think we will do a contour instead of a pocket. So let's create a 3D contour path. We can click on our models and generate our contours. I'm going to select this inner path here, right? We'll keep the same end depth offset of 0.1 because we want to cut all the way through our stock. We'll keep the same tool and we'll keep the same feeds and speeds for brass. But this time you want to make sure that you select inside for your path strategy. So that way the bit will run along the inside of this part. We want to enable ramping, and this will leave a cylinder, a piece of stock remaining. So again, this is where you might need a tab to hold that cylinder in place, or in the case that I'm using, double-sided tape, because there will be a small cylinder remaining after that contour is cut. And now the last toolpath that we need to create is the outer contour for this part. So we can make one more 3D contour. Let's click on our model and generate. This time we'll select this outer ring. Same end depth offset, same bit, same feeds and speeds, but outside for our path strategy. And again, still enable ramping and consider if you need tabs or not. So there we go. So those are those parts. And I think at that point we have everything here. So one last time, let's go ahead and preview our toolpaths. And if you want, you can preview all of them or just the ones that you didn't preview earlier. Let's go ahead and see what this looks like. I'll hide my model, increase the speed, and we can check this out. So the slide parts will be done first, then our pin parts. And that cylinder is what I mentioned would be remaining. So this cylinder, if it's not secured with double-sided tape or a tab, will vibrate around and is something that will need to be secured, or else it might eject from the machine. So keep that in mind depending on how you choose to secure your stock. But there we go. Our toolpaths look great. We can exit this preview and then export these toolpaths for the remaining components before moving on to manufacturing this project.
So with the G-code exported, we're now ready to start to manufacture our designs. We'll first make the base part, and as you can see, I'm using the second anchor point position on the bed of my Carvera Air. This corner clamp is a bit too tall to machine my part with, but I can use it to square up and position my stock, then clamp the stock using lower profile top clamps instead. With the stock secure, we can upload the G-code that we created earlier using the Makera controller app. Starting with the base file, we can open the Run and Config window to set the machining parameters of this part. You want to ensure that the position of the design corresponds to the same position that the stock has been secured. You also may need to add a small offset position to your design within the stock, depending on where it was aligned in the CAM project. We also want to enable scan margin. This will trace the perimeter of our designs before machining it to ensure that the position is correct. And we want to enable Auto Z Probe, which will measure the height of the stock automatically. Now, if we weren't surfacing the face of our stock as we set up in our CAM, we might also want to enable auto leveling, which will actually probe our stock in multiple points and then compensate for any deviations automatically. Once everything's been set, we can press run to start the job. After the automatic scan margin and probing sequence are complete, we'll be prompted to load our first and only tool for the base file, which is that 3.175 by 25 mm end mill for metal. The Carvera Air will then work through our toolpaths, from the surfacing operation to the pocket operation, followed by the final contour operation. We typically don't use a dust collector for metal, but instead use an air assist system for chip evacuation and cooling. Once complete, we can remove the part, and if you use tabs, you'll have to carefully cut and file them away to release the part from the stock, or if you use double-sided tape, carefully peel away the tape and be mindful of any shavings that may have stuck to the tape during manufacturing. Next, we'll manufacture these small pen parts. Again, we can use the Makera controller app to configure and send the G-code files for our CNC after securing the stock, just like we did earlier. The Carvera Air will again automatically measure the height of our stock before working through the different toolpaths we created in our CAM project. This includes the center holes for the larger slide parts before prompting us for a tool change. We can use the Carvera Air's quick tool change system to quickly load the 3.175 by 25 mm end mill for the remaining operations to machine the pocket and contour paths for the various parts in this file. Remember to never leave your CNC unattended during the machining process. And once again, when everything's complete, carefully remove the part and cut any tabs or remove the tape as needed. So now it's time for post-processing, depending on which file you chose to do. For the more complex file that we shared, there's a couple holes that need to be drilled, as well as a rod that needs to be cut in post-production stages. You could choose to do these manually using a drill press or some saws and hand tools that you might have, or for more advanced users, you can create a secondary file that would allow you to machine these parts using your CNC. It's important to also remember that there is never one way to complete any project, like using woods, plastics, or fibers for some of the parts instead of metal. And remember that there are two different example files shared, each requiring different post-production steps with varying levels of difficulty. After post-processing is complete, it's time for the assembly steps. For the pivoting pieces in the more complex design, simple M3 screws can be used to secure a 3 mm rod that passes through holes drilled all the way through these pen parts. And for the larger ring, we will also need a 3 mm hole drilled so it can fix to the end of your rod. These pivot pieces will just slot into the slide pieces to complete the assembly. And once assembly is complete, we can put our ellipsograph to the test and see how it performs. Thanks for watching, and of course, please don't forget to subscribe and stay tuned for more projects and guides on the Makera channel.